Good day, everyone. Welcome to our tutorial on educational achievement and how we can use regression analysis to investigate what influences student performance. In real life, many students ask, why did I get this grade or what can I do to improve? Today, we'll explore whether study hours, socioeconomic status, and parental involvement can predict a student's academic success. And we use multiple linear regression to analyze this relationship.
Real life problem scenario. Imagine a school wants to help students improve their academic performance, but instead of guessing, they want to look at real data to find out. For example, do students who study more get higher scores, or does a student's family background or parental support affects grades?
Now let's discuss the solution we made to solve the problem. So for the solution, we apply regression analysis to investigate the predictors of student performance, such as study hours, socioeconomic status, and parental involvement. But first, let's define what is regression. So based on what I've searched, regression is a statistical method that helps us understand the relationship between one main outcome. Now, let's take a look at our data. So, this data set is collected via interviews on 20 students. Now that we have our data set, we apply a multiple linear regression model to predict student exam scores. So the formula looks like this. Exam score is equal to B0 plus B1 represents to study hours, plus B2 represents to socioeconomic status, plus B3 represents to parental involvement. In our model, B1 is about 2.10, meaning for every additional R a student studies, their exam score increases by around 2.1 points. B2 is about 3.41, so students from higher socioeconomic background tends to score slightly better. B3 is about 2.41, showing that students with more involved parents also perform better. So the intercept P0 is around 0.72, but since intercepts aren't always meaningful and educational data, we focus more on the predictors. So overall, each factor positively contributes to student success. Here we see a scatter plot comparing the actual exam scores and the scores predicted by our regression model. So each blue X represents a student. The closer the dots are to the red dashed line, the more accurate the model's predictions are. So if a point is exactly on the line, it means the prediction was perfect. And if a point is slightly off, the model still made a good estimate. So we can observe that the most points are clustered close to the line, which tells us that our model is doing a good job predicting exam scores based on study hours, socioeconomic status, and parental involvement. So when we look at the results, we find a few important things. That study hours had the strongest positive effect, meaning time spent studying is a major factor in improving scores. While parental involvement also had significant positive impact, showing how important family support is. And socioeconomic status had a smaller but still positive effect, meaning students from better economic backgrounds tend to perform slightly better. Finally, the R-squared value is 0.84, meaning our model explains about 84% of variability in exam scores. This is a strong model fit, suggesting that the factors we choose are very good predictors of student performance.
To wrap up, our regression analysis showed that study hours are the most important predictor of academic performance. Students with involved parents also tend to perform better. Socioeconomic status has an impact but not as strong as the other two. So what does this mean? Students can improve their grades by managing their study time better and involving their families more in their learning. And that's the power of regression, helping us turn data into real insights. And that's all, and thank you for watching.